webinar. Welcome to everyone. I can see that we have attendees from a very great variety of countries in Europe, and not only in Europe, and also some people from overseas. I would like to introduce myself. My name is Andres Ortega. I'm regional manager for Europe in Aquestia, and together with me is Guy Ben Shlomo, who is the product manager for this UpAir technology that we are going to introduce today. The target of the webinar is to make a formal launch with our customer of this new innovative technology that Aquestia is proposing. As always, we try to be at the forefront of the market with new solutions that can bring value to our customer, and we really think that this is going to be a game changer in the industry. We are introducing a new concept, something that we see this as a very innovative solution, and we want to share it with you today to give you some insight, to let you know how it works and what we are proposing. The presentation will take around 35 to 40 minutes. Guy will be taking over it. You can see there is a questions and answers section where you can feel free to post your questions. If you think that there is something that you want to highlight, your comments, and by the end of the session, we will comment on that. So once again, thank you for joining. Guy, the floor is yours.
Hey everyone, my name is Guy Ben Shlomo. I'm working in a smart solution department in Aquestia. Can you hear me, Andres?
Yes, perfect.
Yes, great. And in the smart solution, our focus is to bring IoTs and technology to our traditional product and providing an access to the customer to the knowledge that we have in Aquestia on hydraulic and hydraulic solutions, and bringing a solution to the market, not the product, the solution itself that is bringing value, real value, that we can show. So the first question that I had in mind when I start working in Aquestia is, why should we monitor air valve? And when I started to do some digging in the internet and do discovery as a product manager, I saw some articles about utilities that told the villages to boil the water due to cross contamination, or residents that need to preserve water because of air valve that was breaking. And to have some examples of what can happen to a pipe due to non-functional air valve. And it's not always because the air valve is not properly functioning. It's because someone see the air valve, someone see the air valve a little bit of dripping, and it closed the valve below, and the air valve can function in this way. So this is this critical product that is on our infrastructure is making sure that the infrastructure health will be good and the efficiency will preserve. When I added to the discovery, what can we bring with the device that is connected to the air valve, and how can we bring the access to hydraulic knowledge that we have in the company, I saw many articles about how hydraulic issues can create damage to the infrastructure or to the public, and how much money utilities can spend over one burst of pipeline because of water hammer that was running. And the day-to-day of the utilities are not the catastrophes. The day-to-day is the customer that complains because one resident have a lack of pressure in his building, or he can't. The dishwasher it doesn't work because of a problem in pressure, and the utility need to see if it's on their jurisdiction and send the team outside to check it, or it's in their resident jurisdiction. And here in Aquestia, we have a product that exists, the A.R.I, that is sensing air valves in the wastewater market today. That is main focus is for environmental protection and to help the customer meet with the regulator requirement. So we won't get fines because of sewage spillage. In the UpAir, the new product, we are aiming mainly to focus waterworks, monitoring strategic pipeline, and giving detection for hydraulic events. And actually, for us, we don't look on the product itself, we look about the solution that we can give to the customer. We have two solutions in mind that we are focusing from the discovery session that we do with the customers outside. One is how we can protect critical water infrastructure. The second one is advanced transient and hydraulic diagnostic. And I will show some case studies to two of those solutions that we can present. The first one, protecting critical infrastructure. All of us know that the pipeline are aging and the access to the pipeline is limited in most of the times. Sometimes they are in remote places, and we have a lot of blind spots to those pipelines. And we also know that there are sediments that can be sinking in the pipeline and creating pressure drop over the time. And how we can address those two challenges, we try to address it in two levels. The first one is the network. We are in the UpAir, we are monitoring the pipeline, and I will show a case study that related to that. We are monitoring a pipeline with some critical location, and we are doing hydraulic gradient along the pipeline, dynamic hydraulic gradient along the pipeline. And if we see changes in the hydraulic gradient, we can indicate on issues that can happen along the pipe. And the second level that we're doing it's on the air valve itself, because we are air valve producers, Aquestia, and we familiar with air valves. We can know if the air valve is functioning right and detect if there is any leakage, or some employee closed the valve below it because he saw it a little bit of dripping. And this insight is critical to the customer at the end. And we did one, we have a case study where we monitor a village with 1,000 residents, that most of the time suffer from low pressure. What we did, we installed the UpAir in the critical point together with the utility, with their insights. And one of the days, and they didn't know exactly if the problem for the low pressure is because they have sediments that are sinking or because the source of the pressure is low. And one of the days, actually, they had increase of pressure that was 5 bars more than they used to. They got a notification from the UpAir, and they saw that the national water supplier gave them 5 bars more. And this thing create a burst to the pipes. We gave them the indication, and they talk with the national water supplier to reduce the pressure and to get it back to normal. And we are also working together with them to bring them the full solution and adding hydraulic control valve that is pressure reducing to avoid the pressure increase with the small head loss. Another case study that we have that related to critical infrastructure is a Spanish city that have like 50,000 residents, more or less, that get their water from a river, a dam that closed the river, send the water by pipeline to a water treatment plant by gravitation with 10 meters height difference between the dam and the treatment plant. And what we saw in this case study is actually is related that we are the one that also monitor and bring the solution to this issue. Most of the air valve doesn't close in this low pressure, and as you can see, there is between 0.25 to 0.3 bar. It's a 3 meter, 2 meters pressure in those pipes. It's a remote location, and this we bring them the solution also with the D16L that can close in 50 centimeters. This is one that we install on the pipe, and also we are monitoring to see the pipe function and to see if there is sediments from the river that can sink and block the pipe and reduce the pressure that is also low in the beginning. And actually, this was an interesting commissioning because we are in a pit, and it's monitored, and it's a remote location outside the city where the access to the utility is limited. The utility doesn't like to send people to the field all the time, only to check the valves. And here they can do it from remote, pretty easy. The second solution that we are targeting is hydraulic diagnostics. And actually, as we all know, there are many hydraulic issues that the water network face that are not familiar with the utilities, and sometimes we don't relate the burst from the pipeline or the damage that happened to our infrastructure to water hammer or vacuum condition that can happen in a pipe, or overpressure that can cause those damages to the infrastructure. And here we have another great case study that we did with a big water supplier that told us that he see a problem in a pumping station, that he see a problem in his non-return valve. He had a non-return valve that is connected to the pumping station, that you see that the non-return valve moves over time and the screws that are connected to the floor are moving. And after we monitor this location, we saw that there is water hammer that every time that the pump stops, water hammer that go back and forward for 40 minutes and doing this damage to the customer. And when working with the application engineers that we have in Aquestia and analyzing the situation, we gave them two advice. They have bladder tanks over there that's supposed to reduce this water hammer. First, we told them to calibrate the bladder tank so they will avoid those issues. And the second solution that we gave them is putting a hydraulic control valve for pumping station that will close slowly at the end when the pump stops and avoiding this water hammer. And actually, it get into their work plan and they will commission it according to their timeline. And you can think together with us about which solution we can bring more with this device that have pressure monitoring every 10 seconds as the default, but we can change it. We can do, if we detect abnormality or we can detect that the valve is moving, tilted or tampered, we can activate fast sampling that goes up to 100 hertz, that it's 100 times in 1 second. And in this way, we can detect water hammer if necessary. The second feature that we have, that is in the cloud. We send all the data to the cloud from UpAirs that are in the same pipeline, and we can do hydraulic gradient along the pipeline and do it dynamically and see changes in the hydraulic gradient and give notification if we see those changes. We also have air valve leakage detection and air valve operation. We can also check if the air valve is tilted or tampered. And we also added to the logger the ability for the customer to add sensors that is on for his own, so we can see it in the cloud, in our cloud, and we can also edit like flow sensor or humidity or any other sensor. And this product is a low maintenance with a battery that lasts for 5 years for transmission and data accumulating. Let's go. We also added a website to the data so the customer can visual this the data from the UpAir on their pipeline, and we also have an API. If the customer would like to pull the data to their own software, they can do it with the REST API that is already integrated to this platform. We are monitoring the air valves themselves in the monitoring window. And we also monitoring the devices. So if there is any issue with communication from some reason, a day with fog or something that can cause those issue, we detect it and give this insight to the operational team. We also can send push notification or alerts from email, and we have our application that I will showcase in a minute. And we also have reports that the customer can pull out on his own and get statistics on the hours of the day or the events that happened to him over time. And we can gather statistics on all the events and all the raw data of the UpAir and all the other devices that is in his network. We have the mobile application that in the beginning, it was only for commissioning processes. So it will be easier to the field engineer to do the commissioning fast and smoothly. But we understand from our customer, we understand that they would like to get the information to their mobile. It's more convenient. Sometimes they are in the field, they are in their car, and they need to get this data. So we gave them a push notification, and they can go in to the device and see the data from the device. They can also see it in a graph that is clear to see the behavior of the point. And the commissioning process is easy. We only screw the device to the air valve body, and then we can add the leak detection to the outlet of the air valve, and adding a pressure sensor with a push-pull connection to the lower drainage of the air valve itself. And I now will give the stage to Andres. We can't hear you, Andres.
I was mute.
Okay.
So just to sum up the presentation, A.R.I, we try to be at the forefront of the air management and bringing new advanced solutions to the market. This is a new, total new innovation. We think most of our customers, when we ask them, how many airbags do you have? They don't even know where they have the airbags. So they don't know if they are working properly or not. So that's the motivation to develop this. We know that the airbags are critical devices, that they are not always working, but if they do not work when they have to do, it can generate critical failures. So that's why we have developed this solution that we have introduced today. It is now in the past for potable water. We also used to have the A.R.I sense. Now we have this UpAir. The UpAir will allow us to go to the large critical mains, like for example the case study that Guy was introducing on a 50,000 people. I think it's a the air valves are 6 inches, quite big. In the past we were not able to monitor these big air valves. Now we can do it. We have these options. The bigger the pipe, the bigger the air valve, and the more critical, the more important, and the more attention the customer should pay to it. This device should allow us to extend the lifespan of the asset. We know that this is now a hot topic, especially in Europe. In many places, customers are asking for what is 25, or I have heard even of 50 years extended lifespan for the asset. This tool can help to do this, because if there is any problem, it will give a warning, and the water utility, the end customer, can prepare, can do some maintenance when needed. We also have an option to retrofit. We know that there are thousands of air valve in the field, so it's not an option to ask the customer to replace everything. So that's why we have developed an alternative that you can retrofit on existing air valves in the field. So if you have a customer, for example, using 20, 50, 100 units of A.R.I air valves, we can propose a solution to adapt this UpAir technology to the existing air valves in the field. So this was the very briefly. We don't want to go too much into the details, because it will take quite long. But this was the presentation that we wanted to introduce today. We wanted you to be aware of this new technology. If you are interested, if you want to go, if you want to try, if you want to know more, please do not hesitate to reach us. We will be more than happy to help you. I see that we have some questions on the Q&A section. So, for example, here I can see one. What is the average installation time of an UpAir device on an existing A.R.I air valve? So, Guy, maybe you have more experience on this.
Yes, great question. We started in 1 hour installation time, and today we are in 30 minutes, and we are aiming to get it to 20 minutes and less. So this is the installation time. Of course, it depends on the air valve, and the air valve, let's say, model. If he have a low drainage, but the time to install UpAir to an air valve, it's like 20-30 minutes. This is the commissioning time.
Okay. Another question: the UpAir can be fit to any air valve, not only Aquestia. Is it possible to retrofit the UpAir on air valve from other suppliers?
That's a great question. At the beginning, we are working with Aquestia air valves. Maybe in the future we will do it, but for now we are working only on Aquestia air valves.
Okay. Another question is, how often the product log data? Is it programmable? Can we replace battery in the field?
First, you can't replace battery in the field. It's very simple. I didn't present it, but it's a simple procedure. And if there is a communication issue for a day or two, it can preserve data for 7 days. So this is his ability. Yeah.
Okay. What kind of communication protocols are available for the UpAir?
We have it's working cellular communication, 4G and 2G. We also will add in the future NB-IoT, but today it's 4G and 2G. This is the main communication protocol. We have CAT-M and CAT-1 modems to this product.
Okay, and last question that I see here is it possible to install the software on the customer server? There are many public customers looking for this alternative.
Yes, we can add the web application, and everything is on Azure cloud, Microsoft. So we can ask from Azure to move the server to the country where the customer are locating, but it's optional.
Okay.
Any more questions?
Yes, I see another one here. I think you already replied. Average installation time of an UpAir on an existing A.R.I, you said 25 to 30 minutes. Okay, so I don't see any more question. Well, so we reached to the end of this webinar. So thank you all for joining. It's been great to see you here. Well, if you have here Guy contact detail, if you want to make any question, you also have, most of you already know me and you have my contact details, so feel free to reach us. And we look forward to keep working together to introduce this technology with you. We know that it is generating very good expectations in the market. Customers seems to be really interested in paying more attention to the airbags. So far, they didn't do so well with the airbag. They want to. We see that there is an interest to improve performance, mainly driven by factors like the energy saving and the cost, the rising cost. So we are ready here for you. Thank you all for joining. Have a good day. Enjoy your vacation and see you soon.